This is geometry. Talking about Unit 10. Talk about three-dimensional figures and some two-dimensional figures. A polyhedron. A polyhedron is a solid that is bounded by polygons that enclose a single region of space. So this here would be considered a prism. That is a type of polyhedron. There's lots of different types of polyhedron. A base is a polygon that is used to name the polyhedron. So the base is not always sitting on its base. Sometimes it's sitting sideways. And the base, I look at it as the shape that's being repeated all the way through, from one end to another. Often the top to the bottom, but in some cases the left to the right. You just have to look at the shape and see if it's sitting on its side or if it's sitting on its base. A base is a polygon that is named to name the polyhedron. There are always less faces than edges. And we'll talk about a relationship. We have the number of faces plus the number of vertices are going to equal the number of edges plus 2. That is a formula you need to use. Let's take a look at what some of those words would mean. The F is faces. In this case, the face is, we have a base. We have a base in the back. So that's 1, 2. We have 2 bases. They are considered faces. And then we have 6 different sides, six different rectangles. So that's a total of 8 faces for this hexagonal prism. So we could say that that was 8 for our faces. The vertices. The vertice is where these different edges, where 3 vertices, or where 3 edges come together in this case. It's where the points are on the polygon. Those are vertices. In this case, we have 6 on this hexagon and 6 on that hexagon. There are 12 total for this shape. The edges. The edges are the lines that are connecting the vertices together. The edges are formed by 2 sides coming together. So of course we have 6 edges to make up the hexagon. We have 6 edges to make up the other hexagon. And of course we have 6 edges that are connecting the vertices of each together. So that is 18. 18 edges in this hexagonal, or in this, hexagonal prism. So if you look at our equation, 8 plus 12 is making 20, and 18 plus 2 is making 20. So the way that some of these questions will be formed is, how many faces would a prism have if it had 12 vertices and 18 edges? So you would put your 12 in the vertices spot. You put the 18 in the edges spot. You would know that 18 plus 2 makes 20. You would subtract the 12 across, and you'll find out that your faces would have to equal 8. You would solve it like an algebra problem. You could solve for any piece that you were looking for. You would need to know 2 of them, and you could solve for any one of them. This is just an algebra problem. But you need to know what the formula looks like. So we have the faces plus vertices equals edges plus 2. So let's take a look at the vertices. The vertices are the points that make it be a hexagon. And then you would have 6 of them. Since this is a hexagonal prism, there would be 6 more on that side. So that's why we would call it 6 plus 6 is 12 vertices. That's where we're looking to see where they would be. And then the edges are when you connect those vertices together. You would have 6 here. You would have 6 there. And you would also have 6 connecting the 6 together. And that would be, the edges are in blue and the vertices are in green. Okay, we're going to look at polyhedra, which is, each one of these is called a polyhedron. 2 very typical polyhedron is a pyramid or a prism. A pyramid will always have one base, and the sides are made up of triangles, and they come up to a single point. You probably have a pretty good visual of pyramids. These, we have the base, whatever the base is. Sometimes it's a 4-sided base, sometimes it's a 6-sided base. You can be a 5-sided base. The other sides are triangles. In a prism, you have the bases. And in this case, it's a 5-sided. It's a pentagon. In this case, it has 4 sides, so we call it rectangular. This one up here was a prism, and it was a hexagon for a base. And it's a hexagon all the way through the shape. This is a pentagon all the way through the shape. In the middle it's a pentagon, at the bottom it's a pentagon. The other sides are rectangles. So the sides are rectangles. And this is a polyhedra, singular, polyhedron, multiple. This is not a polyhedra. Notice that the sides are not made up of rectangles or any polygon. It's made up of a circle, it's made up of curve. This is a ball type shape. So we call this a cone. This is a sphere. This is a can of soup. Typically call it a cylinder. So notice we don't have any polygons. You can't have any non-polygons to be a polyhedron. So we come on over here to our first one. You could pause the video. Tell whether the shape is a polyhedron. And if it is, then name the polyhedron. You're going to name it by its shape. Like we named this one either a pentagonal or a pentagonal prism. this would be a square pyramid. This one, of course, was a hexagonal prism. So those are examples of naming polyhedron. So you come down here, you try to name those, pause the video, and give that a try. All right, giving you a chance to take a look at it. I see that we're made up of triangles. That's what this one talked about. They're coming to a point. So this is a pyramid. The base that works its way up to a point has 6 sides. Hexagonal, pyramid. This one here is like a shoebox. You could consider the bottom to be the base and the top to be the base, or you might turn it sideways, stand it up, and now you have a base on the bottom and a base on the top. So the bases are not always what it sits on. But no matter how you look at this one, we have a rectangle for its base, and we have rectangles for sides. So if you have rectangle for sides, then you're a prism. So it's a rectangular prism. This is not a polyhedron. Okay, I think a little bit ago I talked about how polyhedra was singular. Polyhedra is plural. Polyhedron is a single item. Okay, this is a tricky one. This gets a lot of people. What's the shape that's being repeated all the way through it? We talked about here how it's a rectangle. Again and again and again, a rectangle all the way from any side you go from, it's going to be a rectangle all the way through. This is a hexagon on the bottom. It's a hexagon in the middle. It's a hexagon near the top. It goes all the way to a point, though, so that's why it's a pyramid. This is a triangle in the front, a triangle in the middle, a triangle near the end, and then a triangle on the back. So we call it a triangular prism, because the sides are made up of rectangles. Just like this has sides made up of rectangles. This one is sitting on the base. This one is not sitting on the base. So it's kind of misleading. But notice that the base is not going straight up. It keeps getting smaller and smaller and smaller. So it's not having the same shape repeated. It's having the same triangle repeated throughout the shape. This one here, not a polyhedron. Circular all the way through, so we could call this one a cylinder. This one here had a half a cylinder with it. It had a rectangular prism and half a cylinder, but the half cylinder is what made it not be a polyhedron. You can't have a curved section. It's got to be made up of polygons. And curving that just makes it not a polyhedron. If we look closely, we see that we have 1 tick mark on the sides there and 2 tick marks on the sides here. So that's going to make this a rectangle because it has right angles. So this is a rectangular prism. I'm sorry, rectangular pyramid. Now, if we take a quick look at some of these, just for practice, we notice that this has 1, 2, 3, 4, 5 vertices. The edges would be 1, 2, 3, 4, 5, 6, 7, 8. There are 8 edges. The faces, there's one on the bottom, the rectangle that's on the bottom, plus there's the 4 triangles that make up the sides, so that's 5 faces. So using our formula, faces plus vertices equals edges plus 2. Our faces is 5. Our vertices is 5. Our edges is 8 plus 2. 5 and 5 make 8. 5 plus 5 make 10. And 8 and 2 make 10. So they're equal on both sides. So that's an example of identifying the vertices, identifying the edges, and identifying the faces. So if we came to this one real quick, let's just think about this. 1, 2, 3, 4, 5, 6. We have 6 vertices. And we have a front and a back. That makes 2. Plus the 3 rectangles. So that's 5 edges. Or we'll call those faces. 5 faces. We can calculate for the number of edges. Using our formula, F plus V equals E plus 2. We had 5 faces. We had 6 vertices equals E plus 2. That makes 11 equals E plus 2. To use your algebra to calculate the number of edges, so I calculated 9 of them. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that worked out. So that's how you use that formula. Cross-section. A cross-section is when you take a plane and cut your polyhedron, actually your solid really, into parts. Is a plane the intersection of a plane and a solid. Now, where people misunderstand, they think that it's going to be the 3-dimensional shape that's left over. It's not the 3-dimensional shape we're interested. The cross-section is what shape, what 2-dimensional shape is touching the plane. Like what stamp have you made? This is a triangle because that's the shape that the plane would be creating if it sliced into it. This is a sphere, and if you slice off the top, we're not talking about the dome part. We don't want the 3-dimensional shape. We just want the 2-dimensional shape, and that would be a circle. Here we have a pentagonal or pentagonal prism, and if you put your cross section through there, look that it's parallel to the base. So we're going to get a pentagon. Here we have a cylinder. And we are running our cross section from the base to the base. We're not running it parallel. Parallel would be straight up and down. This is running perpendicular to each of the bases. And notice that we are making a rectangle. So that is sometimes surprising that you can make a rectangle out of a cylinder. And then here we have a pentagonal prism. Pentagonal. And we are doing our cross section, our slicing. You can think about it like slicing the bread. We're slicing the bread that is parallel to the bases. So we're going to get a pentagon every time we slice this loaf of bread. Here we had a cylinder. If you want to think about this being a cake, you have a cylinder, and if you cut the cake from circle to circle, you're going to have a rectangle. If you would have cut it this way, you would have created a circle. So you got to decide, are you going parallel with the bases, or are you going in a different direction? The other obvious way is to think about perpendicular, but you can also do some other funny cross sections. But a pentagon would be the last one. And what do we notice about the shape of the cross section when it is parallel to the base of the solid? We've already talked about it. The cross section parallel to the base. Let's talk about what that means again. This one here is parallel to the base. We've got the floor. This would be like a ceiling, and the top would be a pentagon. This is not parallel to the bases. This is perpendicular to the bases. This one's parallel to the bases. So the cross section parallel to the bases is the shape of the base. And then our last couple questions here. We're taking this two-dimensional shape, kind of like what I have here. This two-dimensional shape, and we're spinning it around. What shape would you say this is creating if you look at it from a three-dimensional point of view? This is going out, then around, comes back. This one here is going out, around, and back together. So what shape did you make? A cylinder. This one's a little trickier. This one was spinning it along the y-axis. This one is spinning it along the x-axis. So it's going to curve this way and that way. So here we have a cone. If you spin it around the x-axis, this pointy thing isn't doing anything over here, but this part is being out wide, and then it goes down low and out deep and then back up high. It's making a circular motion. What shape do we see when we spin a circle through a vertical line? It would curve out, it would curve back, and then you have this spherical or sphere that's being created.